Watering the garden takes just a few minutes every day, but if you add all that up, you will spend about 2 days per year just on watering. But it's 21st century, so why not to build an automated solar-powered watering system for this garden? And here is my system. Actually, while making this video, I built two completely different systems for watering the garden. I wasn't quite happy with the first one, but I used it to make really cool graphs, so I built this simplified one that works really well. In this video, I will show you how I build both systems and how you can build them too. I built a similar but much smaller system 4 years ago. Let's just say that it wasn't the best project ever compared to the new one, but it's nice to look back, reflect and see the progress in my making and designing skills. Let's start with an overview of parts and options you have when building such a system. A microcontroller, a board with input and output pins that we can program, that can be any kind of Arduino, ESP, Raspberry Pi, Pico or something similar. There are two ways to realize the watering part. You can use a pump or an electromagnetic valve. Controlling both is very similar. Pump is consuming a bit more current, but you can install it wherever you want with just a small reservoir. You don't need running water. I decided to go with a pump. It's powered with 12 volts and can pump 700 liters of water per hour. Anything similar should work fine. With microcontrollers, we can only control small elements. To control something more powerful like a pump or a valve, we need a relay or a MOSFET. I used both while working on this project. MOSFET is easier to connect and significantly smaller, but the relay can switch higher power. If you want to have an off-grid system, you will have to add a battery, solar panel and a charger. This charger doesn't have MPPT, so it is not the most optimal choice, but should work fine. If you don't need an off-grid solution, you can use a normal 12-volt power supply. The water level sensor will check if there is still water in the reservoir and protect the pump. And honestly, that's it for a very simple system. A system that is dumb because it cannot detect its environment, but you can easily change that with sensors. The most obvious sensor you can add is a soil moisture sensor. There are two types, a resistive sensor with exposed pads that corrode after some time, and a capacitive sensor that, based on my research, should last longer. I thought it would be fun to build my own resistive sensor. Let me tell you that it wasn't fun, but more about that later. Of course, you can measure anything else you want with appropriate sensors like air temperature, ground temperature, sunlight, air humidity, rain and even air composition. To log everything, you might want to use an SD card or you can send it to the cloud via Wi-Fi. Does it make any sense to add all these sensors and log the data on the SD card? Probably not, but after watching a video from Practical Engineering about Arduino Garden Controller, I realized I just want to make cool graphs too. Everything I created while making this project you can find on my GitHub, and there is a link to my GitHub in the description. I also wanted to say a huge thanks to all of my Patreon supporters, because thanks to their support I was able to buy all the parts for this project and experiment with different components. If you would like to support my work, you can find the link to my Patreon in the description. As always, I started with designing it on a paper, and that's the easiest way for me to find the shape and look that I like. Then I moved to Fusion 360 to design both the enclosure and a tiny PCB. I wanted to try out Fusion's built-in PCB design tools. It works basically like Eagle and is easy to use, but I still prefer KiCad. Huge advantage was that it's super easy to get a 3D model of the PCB and design an enclosure. I wanted to machine the PCB on my own with a slightly modded $200 CNC machine. Machining a small PCB like this was a great practice before machining a much larger PCB for my next generation of the watering system. Rods were made out of aluminum, which should help with the corrosion, but it can still oxidize, so still a capacitive sensor is a better choice. My dad probably watered all the tomatoes on the balcony in the morning, so they're all wet and I cannot detect any difference after watering them. Fortunately, I am an expert at drying the plants and I should have some dry plants in my room. And now, watering. During tests, I found that it seems to work better when the top part of the sensor is isolated so that it only detects the moisture on the bottom. I used tape for that on one sensor and shrinkable sleeves on the other. I conducted many tests to check if the sensor works, and to eventually improve it, I tried plotting the values, logging them on the serial port and watering different flowers around my house. The sensor sometimes worked fine, but very often the readings were unreliable and it was really hard to get a stable reading. The plan at this point was just to move on with this project and figure out later if it really works. It's a good idea to test your solar setup too, measure the current that is charging the battery and check the voltages. Combining different modules and sensors in a nice clean way is never an easy task. Helping yourself with a simple CAD design is a smart workaround. And after testing the temperature sensors on a breadboard with just one resistor, it's time to move this thing on a pref board. I've never used a pref board before, but I hope it will be easy. It really wasn't easy. It was even hard. Soldering a PCB is completely different compared to soldering a pref board. It's cool that you can do it really quickly without designing anything on a computer, but I think I still prefer to design my own PCBs. I printed the labels and taped them to the top of the board to know how to connect everything later. Here is a simplified schematic. You can also find all the pin definitions in the top of the code. If you are going to build something similar, you will most likely have to modify something anyway. Here is a great example why using a power supply with current limit is a good idea. I connected the circuit to the battery and soon saw a lot of smoke. Fortunately, it turned out that it was just cables and all the components are fine. I wanted to measure the battery and solar panel voltages, but it looks like connecting the minus from the solar panel to the GND of the circuit creates a short. After getting rid of this connection, everything was fine. I wanted to do an overnight test and eventually the test lasted 48 hours. I was able to make some plots out of the collected data, and here you can see my temperature plot versus the temperature plot from the Wolfram Alpha for my city. With the pump turned off, the current consumption was pretty high at over 80 mA. That was caused by multiple LEDs that are honestly not really needed. When building a system like this, you have to keep in mind how much power is it going to consume and if it will be able to recharge even on a cloudy day. Instead of 3D printing a box that would be hard to waterproof, I bought a 2-liter food container that could easily accommodate both the battery and electronics. Adding cable glands was a nice touch to make sure that everything is waterproof. The last balcony test before installing it in my small garden. It's actually my dad's garden as he mostly takes care of that. I am just helping here and the best way I could help was to automate the watering. Let's just check the current one more time and it's fine, 84 milliamperes. As a reservoir, I use this plastic barrel. This kind of barrels are usually used to store chemicals inside, but this one is clean and was never used. I got it for free, so why not use it for this project? I drilled a few holes for the cables and the plastic tube, and it was basically ready. It's 150 liters, so should be enough for a small garden. My soil moisture sensors weren't working reliably, so I added one more condition in the code to water the garden for a short period of time every 24 hours. I bought online a very cheap irrigation set, and that was just a great way to distribute the water under each plant. Preparing everything beforehand sped up the installation process, but still I had to improvise a few times. Like here, I used a rock and a wire to keep the water level sensor on the bottom of the tank. It easily took me like half a day to set everything up, to change the program, to make sure that it will work at least somehow properly. And now I have to wait a few days, I think like 4 or 5, maybe a week. And there you have the graphs. The vertical lines are labeled every 86 million milliseconds, which is equal to 24 hours. Here you can see that the moisture sensor doesn't work at all. Those drops every 24 hours are caused by the voltage drop on the battery when the pump was turned on. Here you can see the sunlight data and based on that determine how cloudy each day was. At the end of the experiment we can see some cloudy days and it is also visible in the battery voltage data. And lastly, the temperature plots. The air temperature actually wasn't the real air temperature, as I think the sun sometimes was able to hit the sensor directly. My over-engineered system with a lot of sensors was working great, but with this power consumption it would only take a few more cloudy days before it runs out of battery. Desoldering the LEDs could easily solve the problem, but honestly right now I don't need all of these sensors once the plots are ready. And one last thing, I can just simply do better than that. This is not only a project for me, for my dad or for this garden, this is also a YouTube video and I want it to be a decent example of how to create such a system. And this mess of cables is just not working in this case. This time I started with KiCad schematic while parallelly working on a breadboard prototype. Instead of Arduino I chose Raspberry Pi Pico so that I can program it in Python. The capacitive sensor that I found unfortunately is not properly designed and doesn't work with 3.3 volts. The PCB was once again machined on this cheap CNC machine. The result was great, but I intentionally used thicker traces to maximize my chances of success. I probed the wool PCB with chili pepper, that's why the result is perfect, and here I am drilling the holes, which is the easiest part of the process. I wanted to experiment with this PCB and using a toner transfer method I added a legend on top of the board. The result was okay, some small pieces of paper stick to the board and it was hard to remove them, but we have a really nice, readable legend on top. It took me quite a few minutes to place everything as perfectly as it is here, so let's appreciate this shot for at least a few more seconds. Even this DIY PCB without the solder mask is much easier to solder than the pref board. Soldering was an easy part and so was programming since I already had everything planned in my head. Also Pico is programmed in Python and Python, well, it's just the best programming language ever. Everything worked so well that I was able to go from the idea to a working programmed PCB in less than 24 hours in total. Of course there was still the CAD design to do and I had to fit it in the box and do the testing, but I have to admit that the testing procedure was very limited. It was just a fraction of what I did with the previous system because I felt that this one, without the unnecessary sensors and breadboard cables, is just a lot more reliable. Watering will be executed based on time that is set with buttons and it will be displayed with the LEDs. There is two of everything on the PCB, so you can run two completely separate systems for different parts of your garden. The system was ready. I packed everything and I was ready to head to the garden, and then a terrible rain hit. It wasn't a big deal for me, I decided to go anyway and finally finish the project. Checking on my system after 10 days, 12 days already. It is still working. We have the light on the sensor. Here is the other sensor. It is also working fine, and here is the box with the solar panel, and here we should have water. Yeah, the water tank is almost empty. Waiting just one day was definitely worth it because today we have a perfect weather. I want to connect this solar panel to the piece of wood and then put this piece of wood in the ground, and then the box will be here in the bottom just to make it look nice and clean. And then in the next few days I will test how the system performs on a bit bigger garden. It's been a week since I turned on the system and it is working fine without any problems so far. The battery voltage is 14 volts, so even on a cloudy day the battery is almost fully charged. All the plants are fine and now I just need to expand this system for the wall garden. If you have any questions, leave them in the comments and you can find all the useful links in the description. I hope you will build such a system and enjoy it as much as I did. Thank you very much for watching, happy making, bye!